everyone, good afternoon. My name is NCERT. You are watching my beautiful channel Love You Science. So in this lecture what I'm going to do, I'll explain in detail what is the experimental study of photoelectric effect. So what exactly happens in photoelectric emission or photoelectric effect. So mostly we'll be getting question in board exam in terms of graph. So what is the variation of photocurrent with respect to potential anode potential? What is the variation of photocurrent with respect to intensity, or what is the variation of photocurrent with respect to एनोड पोटेंशियल एट डिफरेंट कंडीशन लाइक डिफरेंट फ्रीक्वेंसी में क्या होगा, डिफरेंट इंटेंसिटी में क्या होगा, एंड और भी ग्राफ आ सकता है. व्हाट इज द वेरिएशन ऑफ लाइक स्टॉपिंग पोटेंशियल विथ रेस्पेक्ट टू फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन. मतलब यू नीड टू अंडरस्टैंड ईच एंड एवरी टर्म्स एंड ग्राफ लाइक व्हाट इज स्टॉपिंग पोटेंशियल, व्हाट इज इन फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन, व्हाट इज इंटेंसिटी, व्हाट इज फोटो करंट. सो आई विल एक्सप्लेन इन डिटेल. मतलब फाइनली वी नीड टू नो व्हाट इज द वेरिएशन ऑफ फोटो करंट. What is the variation of photocurrent with respect to intensity of light? That is point number one. That we'll check from here. Okay. And second is the variation of stopping potential with respect to frequency of incident radiation. And third graph will be what is the variation of photocurrent with respect to anode potential at different intensity, keeping frequency as constant. And fourth one is variation of photocurrent with respect to anode potential at different frequency, keeping intensity as constant. So that four graph, ये जो चार graph है, we'll discuss in detail. देखो, here we have a evacuated chamber. In that evacuated chamber we have two electrode. One is cathode which is called photosensitive metal, and second is anode which is called collector. So electrons gets escape out from the cathode and it is being collected to anode. So when light falls on the metal surface or photosensitive plate through this quartz window, then electron get escape out and it will be collected across anode. And the current that constitute photocurrent, that photocurrent will be measured by keeping a microammeter which can measure the photocurrent, and a voltmeter is connected parallel to it which measures the potential difference, and a high tensile battery, a high tensile potential difference is given across cathode and anode. Okay, we can say it is anode potential, and that voltage is given through a potential divider which is called a variable resistor and through a key. So that is all about the experimental study of photoelectric effect. Now we'll discuss what is the variation of current with respect to intensity of light. So पहले तो एक चीज देखते हैं intensity क्या होता है. एक second, let me erase. Intensity क्या होता है? Intensity क्या? Intensity मतलब the number of photon. If light falls on a metal surface from a source, intensity का मतलब होता है the number of photon incident per second. Number of photon incident per second. Number of photon or number of light particle incident per second, that is called intensity. So more is the intensity of light, more is the interaction between electron and photon. Understood? More is the intensity of light, more is the interaction between electron and photon, and then photocurrent will be more. Matlab, if intensity will be more, then photocurrent will be more. So we can say intensity is directly proportional to photocurrent. If I plot a graph, in x-axis if we will take intensity and in y-axis we will take photocurrent, and the graph will be straight line. Then saturation occurs, but here the photocurrent is directly proportional to intensity. Again I repeat, intensity is direct, photocurrent is directly proportional to intensity, because more is the intensity of light, more is the interaction between electron and photon, and more is the chances of flow of electron with respect to time, which is called photocurrent. Clear? Okay, now what is the variation of stopping potential with respect to frequency of incident radiation? That is graph number 2. So from the experiment, what we will find, stopping potential matlab kya hai? It is a negative anode potentials. So now if we change the frequency of incident radiation, what is the variation of stopping potential? Matlab we need to check what is the relation between stopping potential and frequency of incident radiation. See, as per the Einstein photoelectric equation, you know, E is equal to phi naught plus K max. Phi naught क्या है? Phi naught क्या है? Work function. So total energy is equal to sum of work function and K max. अरे ये मैंने लास्ट टाइम बोला था, अगर ये एक मेटल है, when light falls on a metal surface having energy E is equal to h nu, मतलब photon energy is E, then what will happen? Some amount of energy will help to escape out the electron from the metal surface, that is called work function, and rest amount of energy will give kinetic energy to the ejected electron. Getting my point? मतलब here whatever the energy we are giving to a metal from a light source, light मतलब क्या है? Photon. So photon energy is h mu, that is your energy which is given to the metal surface. इनमें से क्या हो रहा है? Some part of energy will help to escape out the electron from the metal surface. ये जो electron है ना, that has to be escape out first. So that amount of energy is called work function, phi naught, and rest amount of energy will help to give maximum kinetic energy to the electron or will help for acceleration. Understood? So this is Einstein photoelectric equation. So from this equation we can get in place of E I can write down h mu. Mu is the frequency of incident radiation. So here it is phi naught, and this one is what? K max. So K max also, in place of K max also you can write down E into V naught. ये V naught क्या है? V naught is the stopping potential. So मतलब this energy will counteract this K max. मतलब stopping potential is a negative anode potential which will block the acceleration of electron. मतलब at stopping potential photocurrent will be 0. So if you multiply electron to the stopping potential, it will be a kind of work done. So that will counteract this K max. मतलब it will block this one. We can write down EV naught is equal to h mu minus phi naught. So what is V naught? V naught is h by E into mu minus phi naught by E. That is your standard expression. So here we can get V naught, which is called stopping potential, and mu is frequency of incident radiation. So now I can write in this way also, in terms of mx plus c. So I have taken y as V naught is y and this one is x, matlab mx minus c. I can write down in this way. So I have taken x as mu and y as V naught. So if I plot the graph, if I have taken mu in x-axis, which is called frequency of incident radiation, and in y-axis I have taken V naught, then what is the nature of graph? mx minus c मतलब इधर ही होगा, ठीक है. सो ये जो पार्ट है, दिस इज कॉल्ड म्यू नॉट, थ्रेशोल्ड फ्रीक्वेंसी. ये क्या है? थ्रेशोल्ड फ्रीक्वेंसी. मतलब if frequency of incidence will be less than threshold frequency, then there will be no photoelectric emission takes place. So the incident of frequency of incident radiation must have more than the threshold frequency. So here look at stopping potential will be 0 at this frequency. This frequency is called threshold frequency. क्या है? Threshold frequency. Understood? So for different metal, it will be getting different threshold frequency, but nature of graph will be same. There are two metal, let A is a metal and B is a metal. Nature of graph will be same, but both are having different threshold frequency. So here what we will conclude from this graph, the first point is, your stopping potential is directly proportional to frequency of incident radiation. मतलब V naught is directly proportional to mu. That is point number 1. And point number 2 is threshold frequency. Threshold frequency क्या है? It is the minimum frequency. It is the minimum frequency below which photoelectric emission cannot take place, above which photoelectric emission can start. So your frequency of incident radiation must be more than threshold frequency. That is point number 2. And point number 3, for different metal you have different threshold frequency, but nature of graph will be same. मतलब nature of graph will be same. Nature of graph for different metal, different photosensitive metal will be same, but mu naught is different. म्यू नॉट मतलब थ्रेशोल्ड फ्रीक्वेंसी. एंड मोस्ट इंपोर्टेंट पॉइंट, फोर्थ पॉइंट, ये जो काइनेटिक एनर्जी, मैक्सिमम काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू frequency of incident radiation. As you know, frequency incident stopping potential is directly proportional to mu naught, and you know there is a relation between V naught and K max. V naught is directly proportional to K max, so we can say K max is directly proportional to mu. So irrespective of any kind of intensity, so it does not depends on intensity. Does not depend on intensity. Okay. So that is all about the variation of stopping potential with respect to frequency. Next is third graph. What is the variation of photocurrent with respect to anode potential? Well, this is very important. What is the variation of photocurrent with respect to this anode potential? But at two different conditions. क्या है? The first condition is at different intensity of light, different intensity of light, keeping frequency as constant or keeping frequency as fixed. Again I repeat, मतलब keeping frequency as constant will take different observation at different intensity. At the same time, if you change the anode potential, what is the variation of current? Very very important. Again I repeat, what is the variation of photocurrent with respect to anode potential? So अगर ये potential हम लोग vary कर रहे हैं, what is the variation of photocurrent? But condition क्या है? Keeping frequency of light as constant by changing the intensity. What is the nature? Okay. तो उसके बाद जो फोर्थ ग्राफ है, at different frequency and constant intensity. तो ये पहले चेक करते हैं. So here I have taken potential in anode potential in x-axis and photocurrent in y-axis because we need to plot this graph. But condition क्या है? At different frequency, different intensity and constant frequency. So now it was found that when when potential anode potential increases, then flow of electron will be faster, then photocurrent will increases. मतलब photocurrent will increases like this. Then it gets saturated. Irrespective of anode potential, photocurrent में कुछ change नहीं होगा. That is called saturation current. क्या है? Saturation current. Saturation current. Okay. Then if we will decrease the potential at a particular potential, will find photocurrent will be zero. ये जो potential है, that potential is called stopping potential V naught. क्या है? Stopping potential. You would have asked, sir, why it will not start from origin? Why it will start from here? Because if in this point, what is the potential? Zero. अगर भी potential zero होगा, still current will flow. Some current will flow due to the energy from that light. So that's why I have taken this part. In this point, the potential will be zero. Still, we have some current. Then, if we increase the potential, current will increases. Then it gets saturated. That current is called saturation current. Then, if we decrease the potential, at a particular potential, we will find photocurrent is zero. That potential is called stopping potential. मतलब ड्यू टू दिस स्टॉपिंग पोटेंशियल जो भी एनर्जी मिल रहा है, दैट एनर्जी विल बैलेंस द काइनेटिक एनर्जी ऑफ मूविंग इलेक्ट्रॉन्स. ओके. सो दैट इज फॉर वन इंटेंसिटी. लेट पर्टिकुलर इंटेंसिटी, ये इंटेंसिटी मान लो कि I1 है. अगेन इफ आई चेंज द इंटेंसिटी ऑफ लाइट, then we'll be getting same nature of graph, but saturation current will be different. ये इंटेंसिटी 2 के लिए देखो, सैचुरेशन करंट, ये सैचुरेशन करंट था फर्स्ट के लिए, ये सेकंड के लिए सैचुरेशन करंट. अंडरस्टूड. देन फॉर थर्ड intensity, if we'll again increase the intensity, also saturation current increases, but nature will be same. Then what will happen? If we decrease the potential, for a particular potential, the electrons, the acceleration of electron stops. मतलब photocurrent will be stopped at this particular potential. This potential is called stopping potential. That means why it happens? Since we have taken frequency as constant. As I have told in my previous slide, stopping potential is directly proportional to what? Frequency. stopping potential is directly proportional to frequency. Since we kept frequency as constant, then obviously stopping potential will be constant. Why? Because on a same metal we are taking different observation at different intensity. I hope it is clear. This graph is clear. Okay, coming to fourth graph. What is the variation of photocurrent? What is the variation of photocurrent with respect to anode potential at different frequency? At different frequency of light and keeping intensity as constant. So matlab if we change the frequency of incident radiation, what is the variation of photocurrent with respect to stopping potential? Matlab parallelly what we are doing here, keeping intensity as constant, if we change the frequency of incident radiation and if we increase or decrease the potential, what is the nature of photocurrent? That is our objective. So it was found, like if I have taken current in x-axis, potential in x-axis, and photocurrent in y-axis, it was found the nature of graph will be like this. So matlab if we increase the positive potential, no doubt photocurrent linearly increases. For a particular instant, saturation occurs. Then now the point is, if we increase the frequency, then what will happen? Your stopping potential will change. For a particular frequency, let this frequency is mu1. For a particular frequency, what is the stopping potential? Let v01. v01 is this stopping potential for that frequency. So now if I increase the frequency keeping intensity as constant, then the nature of graph will be like this. Since intensity is constant, saturation current is also constant, I have told. Now if I increase the frequency, this graph will be like this. So it will be having different stopping potential, let it be V02, but your saturation current will be same. Similarly for third frequency, the graph will be like this. Matlab what you are getting? At different frequency you are getting different stopping potential, and there is only one saturation current since intensity is constant. Okay, so that is all about this graph. So now I'll give one trick how to remember this graph. How to remember, एक चीज याद रखना. ओके, फर्स्ट ग्राफ तो हो गया. ये अगर इंटेंसिटी होगा, ये आपका करंट. सो करंट इज ऑलवेज डायरेक्टली प्रोपोर्शनल टू इंटेंसिटी. मोर इज the photons, more is the intensity of light, more is the interaction between electron and photon, then more is the photocurrent. So it's linear nature. ये तो फर्स्ट ग्राफ हो गया. सेकेंड ग्राफ क्या है? E इक्वल टू क्या है? फाई नॉट प्लस के मैक्स. ये ग्राफ से मैंने बोल दिया था सेकेंड. मतलब इन एक्स एक्सिस योर फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन, वाई एक्सिस में वी नॉट. सो ये ग्राफ ऐसे था. सॉरी, मतलब ग्राफ वाज लाइक दिस. अंडरस्टूड? So to remember third and fourth, I'll give one trick. To remember third and fourth. Third and fourth क्या है? What is the variation of? मतलब variation of current versus stopping potential at different intensity. ठीक है? And second क्या है? Variation of current with respect to stopping potential at different frequency. तो एक चीज याद रखो, हमें तो ये दोनों ग्राफ ड्रा करना है, द वेरिएशन ऑफ करंट विथ रिस्पेक्ट टू पोटेंशियल, बट डिफरेंट इंटेंसिटी डिफरेंट फ्रीक्वेंसी का मतलब क्या है? एक चीज याद रखो, करंट, सैचुरेशन करंट इज डायरेक्टली प्रोपोर्शनल टू इंटेंसिटी. Saturation current is directly proportional to intensity. Okay, and stopping potential is directly proportional to frequency of incident radiation. Understood? मतलब potential is direct, stopping potential is directly proportional to what? मतलब ऐसे याद रखो, voltage is proportional to frequency, current is proportional to intensity. देखो अगर different intensity होगा, different saturation current होगा, मतलब अलग अलग saturation current होगा. different intensity होगा तो different saturation current होगा. बट फ्रीक्वेंसी सेम, मतलब स्टॉपिंग पोटेंशियल क्या है, सेम. एंड सेकेंड ग्राफ क्या था, डिफरेंट. डिफरेंट क्या है, डिफरेंट आपका फ्रीक्वेंसी मतलब डिफरेंट स्टॉपिंग पोटेंशियल, एंड इंटेंसिटी कांस्टेंट मतलब कि सैचुरेशन करंट कांस्टेंट. ये ग्राफ. ओके, so that is all about the graph. So with this I am ending this lectures. I hope you guys understood what I've explained. Thank you so much. Thank you.